Hello everyone, how to solve this problem for the values of k. If we have k times of square root of k is equals to 64, and we solve this problem for all the values of k. So here first we need to remove this square root sign from left hand side, and for this we need to take a squaring on both of the sides, so that when we can take squaring on both of the sides, it will be written as in this form: k times of square root of k and its whole square is equals to 64 and its whole square. So here we use the nice algebraic formula. You know about that. If we have two numbers are multiplied by each other and we can apply its square, so it will be written as a square multiplied by b square. So according to this rule of square, we can apply the square separately on both of these two values, and after applying this, it will be written as k square into square root of k and its whole square is equals to, here we have this is 64, and we write the 64 into the prime factors form, and we know about that the prime factors of 64 are 4 cubed and its whole square. Okay, so in other words, you just say that 64 is equals to 4 cubed. So we replace this 64 equals 4 cubed. And here further in the next step, here we apply another exponential law. You know about that. If we have a to the power of m to the power of n, here we just interchange these two exponents and it does not affect our final answer. So we will write it as a to the power of n to the power of m. Here we just interchange these two exponents. So we need this exponential line on the right hand side, and here we need to interchange these two exponents. So first we focus into the left hand side, and you see here this is our k square. This 2 and this square root are cancelled out by each other and we get k equals to, in the right hand side we interchange these two values and it will becomes 4 square and its whole cubed. And now here in the next step, k square multiplied by k becomes k cubed, and here you see that 4 square and 4 square becomes 16 and its whole cubed. And now we move the 16 from right hand side to the left hand side, and it will becomes k cubed is equals to 16 cubed, and this whole equation is equals to 0. And now you see here this equation will become a cubic equation. So here we use the nice cubic formula. You know about that. If we have a cubed minus b cubed is equals to a minus b times of a square plus ab plus b square. And you see here the base of this term is our a and the base of this term is our b. So after applying this formula, we write our above equation as, so first you have a minus b, the value of a is k minus the value of b is 16, into this is a square, the value of a is k square, plus this is k times of 16 plus b square, and b is 16 square, and this whole equation is equals to 0. And now here in the next step, we need to divide this equation into the two cases. The first case is we write k minus 16 equals to 0, and the second case is we write k square plus 16k plus 16 square is equals to 0. And now here from this case, we easily get the first root of the given equation, and that is k equals to 16. So in order to find the other roots, we need to solve this quadratic equation, and for this here we use the quadratic formula to solve this equation. So first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 16, and c equals to 16 square. And here we state the quadratic formula as k equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is our quadratic formula, and now here we need to substitute the values of a, b and c, and it will be written as the value of b is minus 16 plus minus square root of b square, so b is 16 square minus 4 times of a is 1 and c is 16 square, and it is divided by 2 times of a. So here our a is equals to 1. So further in the next step we need more simplifications, and it will be written as k is equals to minus 16 plus minus square root of, here we need to take common 16 square from both of these two terms. And when we take common 16 square, we get the remaining values are, from here we get 1 minus from here we get only 4. And this whole term is divided by 2 times of 1 is equals to 2. And now here in the next step we have, this is k is equals to minus 16 plus minus. Here we can apply the square root separately on both of these two values, and it will be written as square root of 16 square, and square root of 1 minus 4 becomes minus 3, and it is divided by 2. So here we need more simplifications, and it will be written as, this is minus 16 plus minus, this is this 2 and this square root are gone, and we will get here square root of, we will get here 16 only. And here you see that when negative sign appears inside the square root, it will becomes iota. So this will becomes 16 times square root of 3 into iota, and it is divided by 2. And now here for the simplified forms of the roots, we need to break this fraction, and it will be written as minus 16 divided by 2 plus minus 16 times of square root of 3 divided by 2 into iota. And here we need to cancel these terms, and we get, this is 2 times 8 becomes 16, and we get minus 8 plus minus. From here we have 2 times 8 becomes 16, and we get 8 times of square root of 3 into iota. So these are the other two complex roots of the given equation. And finally we have, there are 3 roots of the given equation. And the first root is k1 equals to 16. This is the real root. And the second root is k2 equals to minus 8 plus minus 8 times of square root of 3 into iota. Plus we can just choose the positive value, this is the second root, and in the third root we choose here the negative value, it is minus 8 times of square root of 3 into iota. So these are the 3 roots of the given equation which we get here in this method, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.